Okay, so quadrilateral family tree, we've already filled in some of this. We've filled in the parallelogram part where we notice that rhombus, rectangle, and square are all parallelograms, therefore they follow the same rules as parallelograms. Today we're going to be focusing on trapezoids and kites. So a trapezoid specifically has one pair of parallel sides, and only one pair. So just to show that on the picture, the bases here are parallel. Then an isosceles trapezoid has two sides that are congruent, just like an isosceles triangle, two sides that are congruent. It also, of course, has these bases parallel. Okay, and a kite over here. A kite has no parallel sides. More specifically, with a kite, the consecutive sides are congruent. So this side is the same measure as this one, and this side is the same measure as this one. Also, we'll go more in depth with this in the lesson, but the diagonals are perpendicular here. So these diagonals form 90-degree angles, and then you also have right triangles. Okay, so that's it for the quadrilateral family tree. Now flip to notes 6-6, where we're going to continue. So 6-6 here. Okay, I know it looks like an entire page worth of notes, but because it was the last page, I just kind of spread it out over the page, so it's not as much as it seems. Starting with the definition of a trapezoid, which we already talked about, it's a quadrilateral, and I'm going to use abbreviations, of course, quadrilateral with exactly one pair of parallel sides. Remember that symbol means parallel. And just to show that on the picture, so this side is parallel to this. There's also some vocabulary here. The parallel sides are called bases, so this is a base and this is a base. And then these two sides here are called legs. So this is a leg, and this is a leg. And then kind of underneath your folder here, there is another trapezoid. Most commonly, a trapezoid looks like this, but it can look like this with the two parallel sides. Another thing is base angles. So angle A and angle D are base angles. So this one and this one. And so is angle B and angle C are base angles. Okay. Here's the next part. Isosceles trapezoid. An isosceles trapezoid, as I mentioned, looks like this. And this side is the same measure as this one. So the legs are congruent. This also means that some of the angle measures are congruent, and we'll get to that in the theorems. Okay, so the first theorem, should I zoom in? The first theorem is if a trapezoid is isosceles, and I'm abbreviating trapezoid as a trapezoid, is isosceles, then each pair of base angles are congruent. And I'm going to draw a picture of this here. So here's our trapezoid. We're saying that it's isosceles, meaning these two sides are the same measure. And that means that this angle is the same measure as this angle. And also this measure is the same measure as this angle. Okay, number 2. If a trapezoid has one pair of congruent base angles, then it's an isosceles trapezoid. So if you're told that the base angles are congruent, then you know that these sides are also congruent. And number 3, a trapezoid is isosceles if and only if the diagonals are congruent. So if on a coordinate plane you had to prove that a trapezoid was isosceles, you could prove that the distance here is the same as the distance here, and you'd be able to prove that it's isosceles. And there's one more that I didn't include for whatever reason, but it's important. This one here. Consecutive angles on a trapezoid are supplementary. So I'm just going to write this off to the side and show you what that means. Consecutive angles on a trapezoid are supplementary. So here's a trapezoid. As you know, the bases are parallel, and what happens here is you have two parallel lines, parallel line, and a transversal. So that means that these two consecutive interior angles are supplementary. So star 1 plus star 2 equals 180 degrees. So if you're given one of these angles, you could figure out the other angle. Okay, now we're going to jump down to mid-segment of a trapezoid. This is something I'm sure you haven't seen. A mid-segment, what is that? It is a line right here. And I'm going to just draw a little arrow and title it mid-segment. With this mid-segment, it breaks these segments exactly in half. It bisects the segment. So this part of the segment is the same length as this part, and this part of the segment is the same length as this part. I'm going to label the corners here. This is going to be point F, E, D, and A, B, C. We'll use that in an equation here in a second. And then, as you know, a trapezoid can look like this as well. And in this case, again, the mid-segment here would bisect these two sides. here. Okay, so the mid-segment theorem states that, are you guys looking up? This length is the average of the length of the bases. So the way it's written out as an equation is the length of BC, EB, BE, however you want to name it, equals 1/2 the length of FA plus DC. So I know writing things as equations can be confusing to people, but if you just add the length of the bases and divide by 2, you'd get the mid-segment. That's it. And we'll practice that in the workbook as well. Then kite. Here's a kite. By definition, a kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. So this side is congruent to this one, and this side is congruent to this one. And then the theorems will further explain this, but the diagonals of a kite are perpendicular. Okay. First theorem, with abbreviations, if a quadrilateral is a kite, its diagonals are perpendicular. And remember, this is a symbol for perpendicular, meaning that diagonals come together to form right angles. And then the second one, if a quadrilateral is a kite, then exactly 1 pair, this talks about the angles, exactly 1 pair of opposite angles are congruent. So in this kite, you have this side congruent to this one congruent here, and then these angles here are congruent. So this angle is congruent to this one. Okay, and then we're going to move over to the workbook 6-6. So get that down and then take out your workbook and open to 6-6.